Hello, my name is Jonathan Calladine and this is my video presentation for my Embedded Systems project. So I decided to make the game Towers of Hanoi, and if you're not familiar with the game, that is a game where there are 3 pegs, and on one of the pegs there is a tower constructed of concentrically smaller discs, and the aim of the game is to reconstruct that tower onto another peg. However, you can only move one disc at a time, and you cannot put a larger disc on top of a smaller disc, making it way more challenging. So, I decided to implement a 2D version of that. So first off, you're shown a title screen, then you're asked to select between a game or a tutorial. So you can select between them with using the joystick by moving it either way. So first we'll look at the game functions, and then you're requested to select a number of discs. Changing the number of discs makes the game easier or harder. Less discs is very easy. The more discs, the more complicated the game is. So we'll start by looking at 3 discs. And then you'll show the game itself. So here are the 3 pegs, here is the tower constructed on one of the pegs, and we're aiming to move the tower to one of these 2 pegs. So you have this arrow pointing to the 3 different pegs, and you can move it with the joystick. You can then select a block by pressing the button in, and then you can move the arrow about to select which peg you want to move it to, and then you can press the peg down. You can press the button down to select that peg, and then you can move it again, select this block, move it along. If you've picked up a block that you don't want to actually move, you can just drop it back down again. Then if we do actually want to move that, we can put it there. And then if you make a false move or an error in putting a larger block on top of a smaller block, this LED flashes to indicate that you've made a mistake. So then what we can do is just finish the game, move this disc here. And then once we move this last disc here, we've reconstructed the tower and we've won. Displays your winning message, and then gives you an analysis on the game. Shows you made 8 moves, the ideal moves is 7, and you made 1 error. So put a wrong size disc. So if we actually win it in the minimum number of moves, it displays a different message. So it still says you're the winner, shows that you've done it in 7 moves, and then says, congratulations, you've won it in the least moves. So now it takes you back to the main menu, and now we can look at the tutorial aspect. So the game is quite complicated, especially when you get to the higher discs. So I decided to implement a tutorial which uses a recursive algorithm, and so you can select the number of discs you want to see. We'll look at 5. So it starts, shows you the tower, and then shows you the moves you need to make in order to complete that. So yes, it implements this with a recursive algorithm, which I've talked about in my projects, in my journals even. And there it is finished, and then it takes you back to the main menu. And it's just, I wanted to mention as well that the way the joystick moves is implemented with a finite state machine, which allows it to wrap around, and that's the same for all the different options, so you can select between all the different numbers. And very briefly, I just wanted to demonstrate my code. I'm not going to do a full run through, but I just wanted to show you a few key aspects, in that I have this version of the code in for the microcontroller, but before I built this, I actually tested the functionality of the code using REPL. So I built the entire game in code using 5 disks, used arrays to represent the pegs, 0 represents a blank spot, and the numbers represent the different size pegs. And then I was able to create the game and have a way of moving the different discs between the arrays. So I've moved the one here. If I do a false move like this, it shows an error. So this worked as the core of the game that I was then able to build all of the additional functionality, like the error indicator LED, like the movement. Instead of typing it in, I could interface that with the joystick. The displaying of the discs on the screen could be, I could convert this array into something that could just be displayed. And then this code, having like a fundamental code version as opposed to the actual microcontroller version, allowed me to actually test different functionalities as well. So I could test the tutorial in the code. So I could run this, and then here it is generating all the different moves I need to make, which could then be used in the microcontroller version. And then here it is with me testing the variable size, so being able to select how big I want the game to be. So with 6 discs, and it generates a 6 disc array. So thank you very much for listening, and that's been my presentation.